I guess, oh yeah, we're capturing the whole screen, are we not? I believe we are. And it's given the fun. Yep, okay. I better mute my speakers or close that window. Okay, it doesn't look too bad. Okay. Let me know if you're able to hear okay. Okay. Finished getting logged in here. Eh. Okay. I don't recall where I left off with this one. Oops. Yeah. That's better. There we go. I don't know if I've added my port forwarding here. I don't think I have. Looks like I have turned on the firewall, however. Just the basics. Uh, 19. Let's see. I forget where it's got to go. After post routing. After post routing, it goes in. Streaming, by the way. Oh, there is an entry for it. Okay. Cut, paste, 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 paste. One, two, two. 102, 2, 2. That should be good for now, just to get started. Ah, dang it. Wrong letter. There we go. Get those put in. And we will... Now you can add them in here manually. And that's perfectly acceptable. Or you can also do it on the terminal. So we have, oops, wrong spot. 1, 102, 0, 100, 101, 102, 16656, 6, 36656. Okay, I feel like it's a little quicker that way myself. Ow, I gotta stop doing that. That hurt like a motherfucker. I have a cut right there still. A bad one. Okay, anyway. Where was I? And there are all our rules already enabled, ready to go. At least at the cluster level. Right. And which one was that again? Ryzen. Okay. What? What's up here? Ah. There it is. Alright. Why can I not get into it? Was it, oh, alright. Why is it unreachable then? Is it just... What have I got wrong in there? Okay, so we have an issue with our port forwarding. Okay, go back. Oh, I know what I bet I did wrong. Well, that's part of it. Okay. Suppose I better make sure I can... hold on. That's what's going on. Okay. Let's see. ENP41S0. That's almost certainly not correct. ENBR0. That's right, because we're not a Proxmox node. That's what's broken. So we're going to just do a set command to replace it all, real quick and easy like. So it's just single quote, letter S, the term you want to search for, the term you want to replace it for. Usually a good idea to put a G in there so it does all of them, otherwise it'll only do the first one. I'll show you that, actually. And then point it at the file we want to point it at. If we go up, we will see it has changed. Oh, it changed all of them. Okay. Just to be on the safe side, we'll give it the global, which is what the G means. And it won't actually write to the file. So this tells you it edits the stream as you put it out, as you use the command. But if you actually read the file without the sed command, the changes have not been made. But if you give the sed command a -I flag, it saves it. Also does not give you the output. And then after that, we will go ahead and I'll just type it. Restore and restore our text file. Now I should be able to access my virtual machine with SSH. So I thought. The -y will just go ahead and install it, so you don't have to hit the type in Y or when it asks you, "Are you sure you want to install this?" Or host seems down. That's good. That's normal. That's what the firewall should be doing. Still filtered. Okay. That looks alright. Maybe it doesn't. Okay, I have to change my IP addresses. That's what I get for not paying attention. So a little more practice with the sed command. Again, the single quote S. And you can use any delimiter character for this. You don't have to use a /. You can use a / if you wanted to, I suppose. Sometimes I've even used a pipe. Hell, we'll use a pipe right now. 172.16. What was it? 100, I think, or 10? 100. 16.100. And we're going to go ahead and replace that with 192.168.212. Give another pipe. G for the global. Our closing single quote. And give it our file name. Make sure it looks good. Looks good. We can give it our -I. And we'll go ahead and restore those. Now, finally, I should be able to SSH into my VM. There we go. See, it looks... we can nmap it now. The PN flag will tell nmap to run regardless of whether it is quote-unquote alive or responding to pings. So, in here, because of the firewall being on in Proxmox, it doesn't respond to pings, so nmap thinks that the host is down when in fact it is not. So you have to give it that -P, N flag, and it will ignore the fact that it seems like it's down and run the scan anyway. And of course the -P10022 is we're specifying a specific port, so only scan this port, because we don't need to waste time scanning other ports. It's the only port we want to know about right now. All right. Start by updating our repositories. Now, I may not remember to explain everything, every little thing I do in the terminal, so you may have to remind me to explain things here and there, but I'll try to do the best I can explaining the little details. So we first go ahead and update our repositories, and we'll go ahead and by installing the essentials. I've got these memorized at this point. Most chains use these. Some may have a few extras. Ryzen, I know, doesn't use anything extra special or anything. It's just a basic chain. JQ, and I usually like to add WireGuard as well. Now, one thing, let me back up a step. I use Zabbix for monitoring. You don't have to use Zabbix. You can use Prometheus and Grafana if you like. You can use TenderDuty. I use TenderDuty along with Zabbix. And Zabbix monitors like the storage space, CPU usage, the normal Linux server aspects that TenderDuty doesn't really monitor, because TenderDuty is specifically really for monitoring the Tendermint aspects, the validator component only, really. And Zabbix does monitor those. You can set it up to monitor it. It's just a little trickier to do so. It has more components that you need to make it work. And it has certain limitations as well as far as how it's set up. But it's still useful, and I still like to use it, because when you combine the two together and make a redundant monitoring system, if one doesn't work, the other one usually will, and it's a nice backup. Usually what tends to break most often with Zabbix actually isn't so much the normal monitoring for like the storage and memory usage and CPU usage, and that's really what I need it for the most anyway on the Zabbix side. The thing that breaks the most on Zabbix is there is a TenderDuty plugin that you can use for it, and that specifically is what usually breaks. I won't get the TenderDuty alerts. Zabbix won't call me if I get jailed, for instance. In some cases, if it's broke, if the TenderDuty monitoring component of Zabbix is broken, which is why having that second aspect with TenderDuty is really useful, because in my experience, some of the ways that you end up setting things up with Proxmox, when I initially started using Zabbix, it was less compatible, and some of those Proxmox aspects ended up breaking Zabbix. So I'm still working with trying to clear some of those up. TenderDuty, on the other hand, is a little more forgiving. Alright, so I'm just grabbing something out of my command reference here on my Discord. Hopefully it'll actually let me copy and paste. It may not. Actually, you know what? It may not. So I'm just going to grab it from the website. Download. Give me a moment here. Bit stuffy. I don't feel like that helped any. All right. I always use 6 because it's a long-term support. Ubuntu 2004 tends to work better in my experience with validators than 22. You can use 22. I've used it successfully. I just feel like 24 is a little more tested. Alright, Nginx. In this case, I'm actually just wanting the agent. And I always use agent 2 Agent 2 is a requirement for the Tendermint monitoring package or template that I use with Zabbix, which is incidentally something that was written by Null at KingNodes. Alright, now we'll just copy that. Whoops. Our shell timed out. So, with Ubuntu and Debian-based distributions, the automated package manager that will take care of dependencies for you is called apt. Dpackage is the individual package manager that will not necessarily take care of dependencies for you. So if you're, for instance, using an old, or I'm assuming this is similar on things like Alma or Rocky Linux. In the old CentOS, it was Yum, which stood for Yellow Dog Update Manager. So Yum in Ubuntu, it would be like apt for the dependency package manager. CentOS, it would be Yum for the dependency package manager, or Red Hat, I guess you could really say. And it probably still is Yum, actually, in Red Hat. And for the non-dependency package manager that does not handle dependencies automatically for you in Red Hat, it is called RPM. So the Debian is a version of individual package management that does not handle dependencies. Dpackage. Because if you notice, it's a deb file extension. Okay, so what that actually does is it just added a repository for Zabbix. So we want to update those, and you'll see them right there. Now we'll go ahead and install all of our packages. Now, there's going to be some differences, perhaps. I don't know if you actually... You said, I think you went through one lesson with the validator school. There might be some differences in how they teach certain things versus how I teach them. A lot of documentation for Cosmos validators will tell you to install specifically Go from the source code, which is kind of painful. I don't like doing it that way. It takes more steps, and even if you're copying and pasting, you still have to copy and paste more. I'll show you how I install Go once we finish with these initial components. I'll just let that run for a minute. Now, we've got our packages installed, but we probably still should update as well. We can install Go before we update. That's not a big deal.
Especially considering how I install Go. So to install the absolute latest that they're really looking for in a lot of cases, you want to give it that channel flag for the 1.19 version instead of the 1.18 version, particularly after the Dragonberry updates. And then you'll have to give it the classic flag. And you have to give it one little thing. In comparison to the source install, it's a good deal simpler. And that's just, you have to modify the path a little bit. Just go. And we don't have the directory there, but we can make it in a second if we need to, or if the compiler doesn't make it. When we compile something or install it there, we can put it there ourselves. Not a big deal. And we will activate the path, or the modification to our profile that we've just made. Oh. Meh. Not a big deal. We'll deal with that in a moment. May have to reboot after this. There's a good likelihood. If you see things like initRD updated, or let's see. initramfs, that's another good indicator. We'll see it at the very beginning. And then ramfs might have been the one I was thinking of. Yeah, I'm pretty sure. initRD, but the point being is that it's in the /boot/initRD, and it has the kernel version after it, 5.4.0-132-generic. That is the kernel version. So that tells you that there's likely something updated that we should probably reboot. Go ahead and do that quick. And we'll just watch the reboot, just so we know when to jump back in. Okay, nice and quick. Oops. Okay. I'm guessing. Yeah. Yeah, that's what it is. Come on. I really just need the git link. There we go. Okay. So, I'm not super worried about the documentation right now. I'm just going to jump right on over to ping. And never a bad idea. I usually grab Pikachu as well. Yeesh. Oof. Turn the light off, please. Thank you. Okay. Ryzen. We'll just go right. Well, yeah. Right to state sync. And no Ryzen over here. But there's a cool thing that you can do. I'll show you. If you find that you have a network that you want to do a state sync for, but Pikachu does not support it, Pikachu has a fantastic script for it. So we'll just make our own. I think it's just .Ryzen. It might be .RyzenD, so we may have to come back and change that. We'll go over here. Yeah, that'll work. We'll just grab both of those. Well, one of them, I guess. I know there's other ones out there. We can go find one if we really need to. Titan-1 and 040 looks to be the version. So, go back to our terminal. Drop that there. Oops. I already had it highlighted. Come on. Alright. Clone our Git repo. Fetch our tags. Great way to know what the latest or what they all are. Boom. Good way to know if there's current development going on as well. I'm not sure 041 is what we need to be using. Ping.pub indicated 040. If it doesn't work, we can just build 041 real quick. But we'll do a checkout real quick. 040. Now there's three targets I typically use. So the word after make is typically referred to as the target. I will typically use make all, make build, or make install. Let's try make all first, and I'll show you why it's not always the greatest idea. Well, it's not that it doesn't. It may not always work, is all. If it doesn't work, you try one of the others, that's all. But make all is good because if you have a chain like Odin or band protocol, something where it has to build a secondary binary, a secondary component of the chain, make all and make install typically as well, admittedly, will usually build both of those binaries. It builds all the components that you need to run the chain. Make build will typically as well, however, make build is not likely to put them in the correct place. Make build usually puts them inside of a build directory in the local Git repository that you have cloned and are now building. Whereas make install and make all have a higher tendency to put them into the go/bin directory of the user that you are currently using. And from there, provided you have made the path alteration that we have already done, those binaries will already be executable as soon as they've finished building. Because the build process actually puts them there. And in this case, our make all looks like it worked. So we're going to check and look and see and go bin, which we didn't make the directory before, but in fact it is already there. And we can execute the binary because we already put the path in our profile. Yes, I did mean version. Thank you. Okay. So, in this case, I'm migrating an existing node, but I'm still going to do an init. But before I do an init, so typically when you do an init, you would do something like this. Right, you got to give it the chain ID. Which would have been Titan 1. I'm not going to do it like that. I like to, anytime I can minimize typing, I'm a big fan. I'm a quick typer, but it's never a bad idea to have to do less work. So, just a little bit of work in the beginning. Well, since we built our binary, we can move out of this for now. Now notice, before it would, I could not do the tab completion. I can show that to you again here. Because we were in the folder that we downloaded, the GitHub repo, and I was trying to do a cd.ryzen, cd.r, and hit tab, or if I actually type it out entirely, or, well, maybe it was Ryzen D. Well, I'm not in the right place. Now I could do it like this. Now that tilde means home. So I could do it like that. And tab completion worked in that instance because it knows, oh, the .ryzen is actually in home and not, it's not part of this, or not part of the repo folder that we downloaded for Ryzen. So anyway. I like to be in the home folder most of the time when I work, because that way it shows you this folder structure that I'm going into and where the files actually are that I'm working on, or that, because if I mean, yes, you would see it in the path if I were, it shows you in the path, and then we do this one. But I like to just show it in the full command. I feel like it just makes it more concise, makes it more understandable.
In this case, we're starting with client. The reason we're starting with client is to give it the chain ID. When you give it the chain ID, you no longer have to type the chain ID all the time, which is fantastic. So now when we go to do our init, it works. We don't have to give it the chain ID. All right, and it looks like it is rise, and I believe that's what we said in our state sync. Yes, right at the end. .rise and config. Okay. Running with no home, I don't know if that's necessary. That's getting a bit extreme. Now, there are points about that are important that we can touch on, but for the most part, when I'm running a validator, I tend to have a non-root user as the validator, or, in this case, we'll look at my example, right? So my non-root user is called Cosmovisor. It does have sudo access. Generally speaking, when you're once your validator is running and you want to start doing actual node lockdown, and this is assuming you're not talking about a more complex validator setup that has something like Horcrux running or sentries or whatever. This is just a single node validator with the key running on it, and you just want to lock it down. And you have a non-root user. The validator should be running as non-root user, so that way the port that you're exposing, the process, if someone, for instance, could cause a buffer overflow or a stack overflow and cause a remote code execution scenario by crashing the binary of the validator, the binary process of the validator, and cause a remote code execution situation, they would only be able to execute code as that non-root user. Now, granted, if that non-root user has sudo and that malicious actor has that non-root user's password, they could potentially escalate to root privileges. So when you get to the point of locking down your validator, there's a lot that you can do. You can remove sudo entirely, or you can simply remove the non-root user from the wheel group. Sometimes it's actually just a sudo group. But effectively, you remove them from the group that allows them to be able to do sudo to access root commands. And at that point, if you need to work on your validator rather than using sudo to get to root, you just simply use the su command, which would look as so. I'd have to set the password quick. Hang on just a moment. Alright, so of course to get to root, I can do sudo su, and that would require the same password that Cosmo, that to do that command, it requires the same password that the user uses to log in. Now, that of course requires that they already have access to sudo. They're in the wheel group.
So if you remove them from the wheel group, sudo would no longer work. If they needed to get to root, they would have to do su. And they would need the root password, which as a different user can be set to a different password than what the non-root user is using. That is one way to lock things down, is to remove sudo access. Another way is to remove password access for SSH login, so that only keys can be allowed. It is also possible to enable two-factor authentication for SSH, but that is a more advanced topic. A better solution, perhaps, is like a YubiKey, or just an SSH. A normal SSH key is a good idea rather than a password. But that's a good way to a good way to start locking things down. There's a lot of different things you can do, and they apply basically to just anything general involving locking down Linux servers as opposed to validators. A lot of the principles are generally the same. But as long as you're running as a non-root user, you're pretty safe. If you're really, really paranoid, I suppose a lot of validators actually provide, or a lot of the chains provide Docker containers, which will put it inside of a jail even further. It puts it inside of a container, and that way it has root access, but only within that container. So it's another cool way of doing it, and giving it another layer of security. I'm not the biggest fan of doing my validators inside of Docker. Other things I will absolutely run inside of Docker, but I don't like running my validators inside of Docker. My experience, and I've only run Odin inside of Docker, admittedly, and testnet at the time, but if you shut down the Docker container, if you have to do things, work on it, it's harder to retain the database from that. It is possible, but it's more difficult than if you're running the validator natively on Linux, as opposed to inside of a Docker container. A little bit of a tangent there. Let's see, where were we? State sync, setting things up, right? We did our init. So we should go and grab seed. Seed. Oh, there we go. So a lot of the time you can find seeds right in the GitHub repo. Seeds or peers. Hopefully we can find some seeds. I see peers, I don't see seeds. So peers and seeds are so... Wait, it does say seed right there. Never mind. I wonder what I'm actually using inside of my main node. So a peer is literally just another person that has the blockchain running that you can connect to be able to receive communication about the blockchain for, and potentially communicate your, if you're a validator, communicate your votes along the blockchain to other peers that way. A validator has what's called PEX, P-E-X, that is peer exchange. So if you can connect to just one peer exchange will allow communication between you and that other peer to be able to get his peers and his peers and their peers, and eventually you can fill out your address book because of peer exchange. And it takes a long time. It's not the preferred way of doing it, but you will eventually get other entries in your address book. And an address book is just a file that contains the the sort of dictionary list of peers that you have connected to, that you have maintained or generated a connection to. So peer exchange, or PAX, if you can connect to just one peer, peer exchange is a mechanism that will build out your address book and allow you to connect to additional peers, even though you only made one peer configured in your configuration file. Now, typically people use persistent peers. What that means is that your node will always try to maintain a connection to that peer. The issue with that is that everybody tends to put the same peers into persistent peers. The problem with that is that means everybody's node will always try to maintain a connection to these certain specific peers. Now, unless that validator operator of that peer happens to have allowed additional connections beyond the default Tendermint settings, they may only be allowing 10, 20 incoming peer connections. And if you've got 100 validators, that's kind of an issue. A seed is a special peer communication node that what it does is it always it's like a blockchain crawler, right? A seed node is. It's always trying to find other peers. That's all it does. That's all. Its only job is to find peers and communicate those peers to the people that request them. Persistent peers are absolutely used in sentries. When you use sentries, there's certain components that have to be activated, other components that have to be deactivated. It's been a minute since I've set it up. Certain nodes you do not want, like the actual, if you're running an instance where you have 3 sentries and 1 validator, and your validator also has your keys on it. That's your signer as well. Your sentries are just full nodes. Then your sentries would have PEX on, but your validator would have PEX off, and typically you have a private link between the validator signing node and your sentry nodes, and that private link may often have a private IP address, and so you wouldn't want to broadcast that into the network. So there's a bunch of specialized settings that you use for sentries. In my opinion, a straight sentry setup is not ideal. It's, as far as Cosmos operations are concerned, it's somewhat antiquated. It's not a bad security idea, but there are improved models now that are better to be used. And the primary model that tends to be used, yes, actually, address book strict has to do with whether or not you will advertise private addresses, if I recall correctly. And it's really only applicable if you're using a plain sentry setup, I think, in my opinion. There are other instances where you may want to disable that. The default setting is for strict to be enabled, which means you will never advertise private addresses, if I recall correctly. I may have to verify that, but in any event, you usually only have to look at it if you're running a standard sentry node setup, which, like I said, is kind of antiquated. Nowadays, the typical setup is for like a Horcrux setup, where you have 2, perhaps 3 full nodes. Now, in the instance of a Horcrux setup, a full node and a sentry are synonymous. They are the same thing, because your Horcrux cluster, the actual component of the whole solution that has the keys on them and does the signing, they don't actually communicate directly with other peers outside of your quote-unquote sentry/full nodes. But you don't need, I mean, it's in my opinion unnecessary and can overcomplicate things and really gives you additional points of failure if you have a layer of sentries and then a layer of full nodes and then your Horcrux nodes. It's really not needed. So having your, in a Horcrux setup, your sentries and your full nodes are the same thing. And in my opinion, you really, if you're doing it well and you're using two separate providers in two separate physical locations, you really only need two sentry / full nodes, and then you want perhaps 4 Horcrux nodes with like a threshold of 2. That way, if 2 of your Horcrux nodes goes down, you still have 2 nodes with which to assemble a full key and remain signing. I'm going to check real quick what... Oops. 114, wasn't it? Yeah, 114. So we're going to check and see what the peer setting is. Hopefully... Come on. Oh, well, whatever. Let's see. I mean, technically, you can get away with 3 signers, but better to have that extra one, because the thing with Horcrux nodes is they're much, much lighter than a full node. You can get away with much less memory, much less CPU resources, and as such, they're much less expensive. So you can spread those out over several providers and have a really, really good availability because of that, and not really be paying much for your Horcrux signers. That's the beauty of Horcrux, and it still gives you a ton of security because you can harden each of those nodes. You could have different, if you're really strongly paranoid, you have different passwords for both the non-root user and the root user on each of your Horcrux cluster nodes, and that means that they have to, and if they have, if you've got a threshold of 2, they have to break into 2 of those nodes to assemble your signing key. If you did 6 nodes, they would have to break into potentially 3 of those nodes to get your signing key. And you can adjust the threshold. For instance, if you wanted to, you can make it so that the threshold is 4, so that there always needs to be 4 nodes up out of, say, perhaps 6 total. There's a lot of ways that you can adjust it, but bear in mind, the more Horcrux nodes that you add, the longer it will take. And this is nanoseconds, but the longer it will take to come to consensus between them. So it does increase the potential that you can miss blocks. And so for instance, if you had 50 Horcrux nodes, you're going to miss more blocks than if you had 5. So I would say maybe 4 to 6 Horcrux nodes would be ideal, depending on the system resources that you can allocate to them and the speed of the processors and such. If you can really get some high-frequency CPUs for your Horcrux nodes, you might be able to add more of them in more locations and really hardly miss any blocks. But high-frequency compute tends to cost more. The really strong security for the future of things outside of like interchain security, that is, and that's a whole other discussion, and I really don't even yet fully understand it myself, but there's 2 real main security mechanisms, and both are good. Both the main idea being to remove your signing key from the validator, which has the most port exposure out of the whole setup, and that is TMKMS, Tendermint Key Management Setup, with which you can use just a software remote signer, or you can use a hardware security module such as UBHSM. You're supposed to be able to use a Nano or a Ledger Nano as well for that. However, I've heard that's broken at the moment. And then Horcrux, of course, which is a soft signer. However, it splits your key into several pieces. Horcrux doesn't work with all chains, mind you. The chain does have to use the proper type of signing, consensus signing key. So, if your chain runs a sec P256K1, I think it is, consensus type key, Horcrux will not work with it. Whereas if it uses an ED25519 key, Horcrux will work with it. That's the type of key you do want. Now, the future that I understand the Horcrux guys are working on is to include HSM, such as a UBHSM with Horcrux. I'm not exactly sure what that will look like, but I think, in my opinion, that will be the granddaddy of all setups. That is really what I'm waiting for, is for those guys to release that final bit, and that is the ultimate goal for me to achieve. I've been able to make TMKMS work. I like it. So far, I kind of prefer Horcrux between the two of those, though. I like them both. They both have their place. But I feel you get better availability with Horcrux and comparable security. Yes, it's not as secure as a hardware security module, perhaps, but you can make it pretty damn strong. So we'll finish just signing in here to grab our seeds. Horcrux is better with double signing. They both have double signing prevention, and so they both have to watch the consensus state and round. No. They both have to watch the consensus state and round that your validator keys are at. Horcrux, I think, is a more robust double signing mechanism, in my opinion, because it's like a validator network for your validator. The Horcrux nodes have to come to a consensus first. And just the way it works, it's very difficult for Horcrux to double sign. Even if you're having multiple full nodes, it doesn't matter, just because of the way Horcrux works. There's a really good, if you go to the Horcrux GitHub, and then actually you have to follow it, I think, to find the actual Raft GitHub. But if you find the Raft GitHub, and the Raft GitHub explains the whole consensus mechanism and how that whole deal works. And then once you add the state component to it and how it monitors the state, the whole deal kind of makes a lot better sense. Horcrux, because of the more robust double signing prevention, is a better solution, in my opinion.
I just dropped my computer. Okay. I have to get something to drink. I will be right back. Let's see. So that's exactly what it's using. Seed 1, seed 2, seed 3. Yep, okay. Let's see. So, I can't remember exactly where it might be in the other article, but no matter what, in a Horcrux cluster, all the full nodes connect to the, if it doesn't matter if the packet reaches one of the Horcrux nodes or the other, because there's always a leader in the Horcrux cluster. And if you watch this diagram, right now, S2 is the elected leader. And it is possible for a new leader to become elected, but effectively that leader has to go down for that to happen. And it's like a small validator network for your validator. I've done a good bit of reading on it, and I'm not sure I could, let's see. That might be it. Here it is, right here. History of this. This is the article. This article here is what explains how it has double signing prevention. So if you read that in the time you have, you should be able to understand why Horcrux is important of a component to the Cosmos ecosystem as it is. More so, I think, in my opinion, than TMKMS. Both are very, very important tools for
greatly increasing the security of your validator. But in my opinion, Horcrux is the better of the two because it provides better high availability. I would say TMKMS may provide stronger security, but it does not really provide any high availability. Not in the same way, because you still have a one single point. If you lose the node that has your HSM, your hardware security module that is connected to it, you stop signing, bar none. That's it. And there's no way that I know of currently to have multiple HSM modules with the same key, which is kind of what Horcrux does. I'm very curious how Horcrux will implement HSMs within it. Will you have one HSM on? I'm so curious how that's going to work. I'm confused about that one, but those guys are smart. I'm sure they'll figure it out. So, back to our terminal. And you know what? We could just copy this if we wanted to, I guess. Alright, let's see. So, I don't usually go and change most of this. I don't really need to change the proxy app, the moniker I set when I do the init. I don't usually change the database backend. I have been curious to try RocksDB on some of the faster chains like Kuji. I hear it is actually really beneficial on chains where you've got a 5-second block time. Unless you really like Juno, where you have a lot of smart contract execution, and you need a lot of system resources, a lot of RAM, a lot of a high frequency CPU to really not miss blocks on Juno. That might benefit from a RocksDB as well, because that way you're cutting back on I/O. So it just might benefit from that. But most chains, is it required? Probably not, so I try not to complicate it with that kind of stuff. Why complicate things and add points of failure if you don't need to? If you're altering the config, to me, that's adding a point of failure because you're changing something effectively. Pretty straightforward as far as the log level. You can change to add more logs if you want, I guess. I don't usually change it. It might be interesting to try JSON log output, but I haven't tried it yet. Of course, the file locations. Now, if you get to the point once we get to the point of doing Horcrux setups, that is what this priv validator L address, that's what that entry is for. So until we get to Horcrux and remote signers, basically where you have your consensus key is not on the node that has the blockchain database on it, that's where you use that configuration directive. Otherwise, you can ignore it. Same file location. I've never changed this. I'm not sure what the purpose of changing it would be. Socket is just basically a direct Unix system connection versus gRPC, which would be basically over the network. In most cases, I would honestly think socket is preferable. So I'm not sure why you would change that. It would be interesting to get a developer perspective on what might be the benefit of changing that, or what the purpose of changing that would be. RPC. Now, I do change this to the instead of the loopback address, which is what 127.0.0.1 is. That means it cannot leave that machine. I change it to bind to all IP addresses, which is what 0.0.0.0 means. It means bind to every single IP on every single network interface that's on this machine. Now, in this instance, we are behind a NAT router because we are a virtual machine on a hypervisor host, which is Proxmox, and that Proxmox host has a single public IP address. So effectively, you can think of it as servers running behind a router, because that's really what it is. So we can expose the ports on this, the RPC port, to all IP addresses, but unless we actually forward that port to the outside world, to the public IP address, and make that port available on the public IP address, it's otherwise safe. So we don't have to worry about it. The firewall's on the Proxmox outside end. So and that helps for monitoring. If, for instance, you want to set the way I set up monitoring, I have a Zabbix server, and then I usually establish a WireGuard link, VPN link, peer-to-peer VPN link between the validator node and the Zabbix server, and that simplifies some of the monitoring processes, particularly the tendermint aspects of it. Being able to bind it to all IP addresses like that instead of just loopback makes it much easier to work with that way. So I typically change that. Occasionally I will allow additional connections, additional peer connections. Most of these settings, however, the subscription stuff, I really don't bother to change. And most of these have to do with, these are all have to do with your RPC settings. So if your RPC isn't a publicly available RPC endpoint, you really don't need to worry about any of that, because nobody's really connecting to it outside of yourself. And generally speaking, you don't want your RPC node available, not on your validator. If you want to provide a public RPC endpoint for a blockchain, you do so with a separate server that does not have your keys on it and is not sending transactions that are being signed with your keys. You just make a separate server for RPC. For instance, you can have an RPC node that serves several. Like you could have the same server serve RPC for Jackal, as well as Ryzen, as well as Vigilant. I'm sure you wouldn't want to put too many on there, because each one is going to take a certain amount of space, and you are going to have to maintain it and everything. But you could run multiple RPC endpoints on the same server. The point being is that you do not want to run a publicly available RPC endpoint on the same node that has anything to do with your validator operations for that chain. So if you're running a publicly available RPC endpoint, basically you're only concerned with this RPC section and not with anything else. And with a validator, if you're running a validator on a service, it doesn't necessarily have to. If you're calling it an archive node, it should. But in the case of most RPC nodes, most people are primarily concerned with recent transactions. So in most cases, an RPC node can be state synced or snapshotted, and it'll be fine. it can an RPC node will function without can function without having the entire blockchain. Let me put it that way. Now, when we go back to the binding RPC to 0.0.0.0, for instance, if you're running your validator on DigitalOcean, Vultr, they put the public IP address directly on the node. So if you bind it to 0.0.0.0 like that, you definitely want to be using the firewall to restrict what can actually connect to that port. If you're hosting, if you're hosting a validator on one of those hosting providers, DigitalOcean, Vultr, what have you, probably better just to leave that bound to the local host instead. But because I run, in our instance, we run many validators or many full nodes on the same server, and they're, virtual machines on a hypervisor. And they're behind a NAT router. Effectively, it's okay to bind them to all IP addresses. And you'll notice the peer-to-peer port is already bound to all IP addresses. All right, so we're going to go ahead and give our address. That Ryzen can be externally accessible on, which is 16656 of PVE5. We just paste our peers in there, or I'm sorry, our seeds in there, and if you have if you have the information available and you can put the preference is always run seeds over peers. Persistent peers are great, but most of the time, unless you're actually doing a traditional Sentry setup, you really don't need to maintain a consistent connection to one specific peer at all times. So seeds are better because the seeds will keep your address book up to date with, for instance, if new validators join the network, they'll get in your address book if you're using a seed much easier and faster than they will through PEX if you're using persistent peers. So always prefer seeds over persistent peers. If you have a lot of chains, especially it's more common at launch time before a few people actually fire up a seed peer, for instance. So Genesis time, it tends to be more common, but there'll be like 15, 20, sometimes more persistent peers configured in here, and that can really make your node be overworked because it's trying to, when it's in persistent peers, it's trying to literally maintain a connection to 30 peers at all times, and that's not really necessary. So better to use seeds over persistent peers. A lot of this other stuff you really don't need to alter. I don't typically turn UPnP on. I just use the default for a false. And I've never had a problem. Even if I don't populate the external address, it still tends to connect okay and work out all right. Address book strict true. We talked about that. You do want to set it to false if you're using Sentry nodes, and that's because typically Sentry nodes will have a public IP connection, and you don't want to normally advertise private IP addresses because they're non-routable across the internet. Now, occasionally, depending on the size of the network and how many types of, I will sometimes modify these. It's not uncommon. I might, like a lot of the times, I'll like to add 5 to the outbound, and then inbound 40. that's higher than most defaults. Like this is usually 10 and this is usually 20. So I'm surprised that it's as high as it is on that one. So we'll just leave 40 alone, and then we'll leave this one at 15. OBS Studio does record. It has the capability of recording at the same time. Hopefully, my recording isn't getting too large here, because I'm not sure how much space I'm running in a virtual machine, so I'm not sure how much space it has. But I'll know because it'll stop working real quick if I run out. But that'd be sad because it might bork my recording. So we'll get the validator set up and we'll stop the recording after that. But we've gone through quite a bit of topics, and that's good. That's very good. Here's the PEC setting. So if you're running sentries, that's where you may have to disable that. It's been a minute since I've done sentries. I shouldn't say you may have to. On certain, if I remember correctly, it's the validator itself that has the signing key that you disable it on, and the sentries itself have them on. But again, sentries, it's kind of an antiquated setup. Horcrux is really better. It's more cost effective. It's less complicated, less points of failure. It's just overall better. Private peer IDs, that is also used for Sentry stuff. We can get into that later once we actually. Sentries is an advanced topic, so seed mode, kind of advanced topic as well. So we'll touch on those later. A lot of these general topics, there's a lot of configuration directives that are in the config file that you will hardly ever touch, honestly. Mempool, I rarely touch anything in Mempool. I rarely touch anything in what's the one before it? Oh, RPC. The peer-to-peer, you mess with a lot of stuff. That's one of the more common sections that you actually do mess with. State sync as well, but I typically don't do that directly. You can go to ping.pub. And if you look here, it's got that section right there, and you can basically just copy that whole section if you want and just dump it right into your config file. I like this the scripts from Polkachu better, and the reason for that is that you can just run the script again, and boom, your file's updated, and you can state sync right again. And I'm actually working on automating that. I haven't had as much success as I would have hoped, but the idea is that you can set it up in like a cron job or something so that it will automatically, when the free space goes below 15%, for instance, it'll automatically stop the blockchain, copy the priv validator state file, do an unsafe reset all, update the state sync information by running the state sync script, and then restart the blockchain. And it can do that automatically. I mean, there's no reason that can't be scripted. I just haven't gotten it working yet. So we'll run the state sync script. I don't really ever change anything in fast sync. Consensus, you may occasionally change things in. Most typically, it's timeout commit. But these settings, you really don't ever change unless someone that has more skill than you tells you to. Even for me. It's rare that I change, I don't change them without someone else telling me to. That's like a dev saying, hey, this is what we have to do to get the chain running better so that we stop missing blocks, or I'm not, that is beyond my skill, I would say, to alter these settings. And it can have a bad effect if you do. You can start missing like insane amounts of blocks. So don't alter the consensus settings unless told to do so. I'm not sure if this ever has to be altered. I've never had to alter it for Horcrux or TMKMS. And like I said, I strongly recommend reading that Horcrux 2.0 release document for a very good explanation on how the double sign protection works. And also, let me get you the link for TMKMS, because that's important on reading to understand how it works for the double signing protection as well. There's a lot of documentation on TMKMS. Not all of it is new. Horcrux is newer. It's more up to date, and it's just better. I'm hoping my Twitch video will be, or not, my OBS video will be good. And I generally don't upload the videos to OBS. I usually put them on YouTube. I'm sorry. I don't upload the videos to like Twitch. I upload the videos to YouTube because they're already streamed on Twitch. Twitch doesn't maintain them, or retain them, I should say. Ones that I've streamed in the past, that I have done with like Chandon, for instance, I don't have all of them on Twitch. I have recordings of some of them, but they really need to be edited because the recordings ended up being in several chunks in a lot of those. So the quality of this recording, if it ends up being usable, I'm excited because this is a lot of data. This is have been able to cram a lot of knowledge in this recording so far, and I'm kind of proud of that. All right. Did I send that link to you? Okay, yes I did. Alright, I don't really do anything with the Prometheus settings. I don't really do anything with the indexer most of the time. It can help the performance. I don't earn the space as well, I understand. But I don't usually mess with the indexer settings. Alright. So we've done that. We run our... We make our state sync script executable. We run our state sync script. And we'll just check and make sure real quick. Yep. Populated. Good, good, good. All right. Next step. Cosmovisor. I don't know. I love Cosmovisor, but when I first learned to use Cosmovisor, I thought you had to sync from block 0. I'm not fully sure I understand indexing, honestly. That's something we should explore together. I know it has to do with the storage size and being able to search through the transactions. But I typically haven't had a problem with it, so I don't usually turn it off. It can help, so we'll look into that. I'm curious to know more about that myself, to be quite honest. Anyway, Cosmovisor. When I first started with Cosmovisor, I thought you had to use Cosmovisor. You had to sync it from block 0. But the truth of the matter is that you can use Cosmovisor and use state sync, get the most recent state sync, use only the most recent version, and then still be able to use Cosmovisor for upgrades and not have to wake up at 3 in the morning to do a chain upgrade. Which is kind of annoying. So using Cosmovisor with state sync, it's the only way to go. It's the best way to learn how to run these things. In my opinion, running Cosmovisor is a requirement. Running state sync is also a requirement. Otherwise, your storage becomes unwieldy, ungainly. There's really no reason for a validator to maintain a copy of the entire blockchain. It's purposeless. The validator doesn't need it. If you want a whole copy of the blockchain, run an archive node and make it a publicly available RPC point. But there's no reason for a validator to keep a record of all the blocks. Its only concern is new blocks, signing new blocks, making new block proposals. It's, there's no real reason for a validator to have a copy of the entire blockchain and to sync from block 0. That being said, a validator does need to be on the most recent binary version, and that's, of course, the usefulness of Cosmovisor. Fetch our tags. And we'll check out Cosmovisor. Oops. 1.3.0. And our target in this case is Cosmovisor. So, in addition to the indexing, one of these days I would also like to experiment with RocksDB a little more. I have a little bit before, but that was because of the fact that state sync wasn't available on a specific chain I was working on, whereas there was one person that provided snapshots. However, in order to use that snapshot, you could not be using the Go level DB that was the default. You had to switch to RocksDB. RocksDB is really fast, like really crazy fast and efficient. It was done by the Facebook team. And it's popular with validators. All right. A lot of the time, to get my Cosmovisor set up, I kind of just cheat. Because I know Odin has a good setup for it available. I'll just go to the Odin GitHub and grab it real quick because I have it in my command reference too. There's a couple different spots you can get it from. And there's a couple different ways you can drop the thing in there. But what we're looking for here is the service file that we want to make. Let's change all our variables here. I think it's Ryzen D. I've found that I don't really need it to be back. It does. I don't find the backup that Cosmovisor does helpful, so I usually just turn it off. Yes, okay, so it is Ryzen D. Enable the service so it turns on at boot. Otherwise, you will have to turn it on every time. Let's see. We have to make our... Now, only the Ryzen folder of those exists so far. If you try to run this command, it will fail. However, if you give it the -p flag, which stands for parents, it will work. Otherwise, you would have to start with make dir Ryzen Cosmovisor, and then you'd have to do make dir Cosmovisor Genesis, and then Cosmovisor Genesis bin. So just give it the -p flag. Makes it easier, quicker, faster. So we'll put our binary in there. And the only other thing left, I think, should be the Genesis file. Oh, yeah, we didn't do our app. I'm sorry. So, we'll go ahead and exit because there was a sed command to do that. No reason to reinvent the wheel, I figure. It tells you, you know, I mean, we could have manually set that. But we can look at the sed command, because I did one earlier, and we can see sed -i, so it's automatically going to go ahead and write instead of trying it first. So we can actually take that out just to see. And we know that there wasn't anything in the minimum gas prices, so if we would run it without the -i, we see it went ahead and put the proper number in for us. And so we look and we see it did the search, minimum gas prices equals, quote, quote, nothing in there. And then it wants to replace it with minimum gas prices equals, blah, blah, blah. What is that? 1/10,000th of a micro atolo. And then it adds the global flag. And, of course, that's the location of the file. So basically, real close to the sed command that we did ourselves. Looks safe to run. So, I mean, you know, you're running somebody else's code. You want to look at what it's doing. That's my point. So we can go ahead and put that -i flag back on there. But we want to go ahead and, because there's other changes that we want to make aside from that. I always turn on pruning. I've only ever had to turn it off a couple of times. But I usually go custom. And in my experience, if you get too much more aggressive than this, you can have issues with your blockchain database getting corrupted. Not a huge issue, however, that if it gets too corrupted, you can, my understanding, I don't know if this is actually fully true or not, but if it gets corrupted, you're pruning heavily, my understanding is there may be potential there to double sign. I don't know if that's actually true or not. Halt height, you may sometimes, like if you're doing an upgrade without Cosmovisor, you can set a halt height That way you can stop. It's basically it helps you stop the blockchain without corrupting the database. I think halt time is basically the same thing, except it gives it I think you have to give it a Unix epoch. Yeah, Unix second. So you do have to give it a Unix epoch. So you'd have to put in like a normal date into a website that does an epoch conversion for you, and then give it the Unix epoch in that, which is a string of numbers. Most of this I don't really turn on. The telemetry I've never really used, so I'm not sure I could explain what it does. I'm interested to learn, however, so maybe perhaps someday we can ask. I think one of the good ones to be would perhaps be Dylan Schultze of Lavender 5. Another good one would be Todd from Blockpain. Both super knowledgeable and readily available. I've talked to both. They'll both answer questions. They may not answer immediately, but they'll answer. I'm not as sure what the IAVL stuff is. I know it has to do with some of it has to do with indexing. Most of the time, I don't really set much in the way of stuff down here. Lately, after the Dragonberry updates, though, there have been a couple settings that have gone in here right ahead of the telemetry config. This is one of them on a few chains, actually, is the IAVL cache size. I always set the API to true. Again, it's similar to the RPC. You do not want to expose your API port publicly, generally, at least not on the node that's running your validator. If you're going to make a publicly available API point, run it on a separate server. That does not have anything to do with you signing blocks. And it already binds to all IPs, if you notice. I've never used the Rosetta part. I'm not really sure what it's supposed to do. I do know Pikachu, I think, makes them available, if I'm not mistaken. Polkachu. I mean, not Pikachu. Maybe not. Anyway. gRPC, it's enabled by default. I don't usually make it available. Occasionally, I have made it available on some chains for like developer access, but I've never made it available publicly. The state syncs bits that are in app.toml are for providing state sync. Whereas the state sync configuration directives that are in the config.toml are for you state syncing your own database. This is for providing state sync availability for other people to state sync their database. I've never turned it on. However, I have plans to make state sync available for some chains in the future, so we will cover that in the future as well. So that goes over app.toml and config.toml. You really don't have to edit anything else. Now the priv validator key and node key, these are we're just using those for syncing, of course, because in this instance I'm actually migrating this node. We have our current Ryzen node is on Hetzner, and I'm migrating it to my data center. So I'm going to go ahead and remove that Genesis file, and that is what was created when we did our init. We don't really need it. In fact, not really. We don't need it at all. I believe this should do it. Whenever you're going to copy a Genesis file, it's almost assuredly a better idea to copy the raw link. Matter of fact, it's almost best bet to open the actual raw link and copy it from the browser with it, the actual raw data, and that's it. That way you know you're getting the 100% the right thing. Then you go ahead and just do a wget and throw your link in there. And you know that that Genesis file is correct, and I can prove it to you. By running this, and we can compare that hash here in a minute. Why is that different? Could not open file. That's why. That's why it's not working, because it's not in the right spot. Now we're getting the right hash. Okay, so our Genesis hash looks good. We compared it. Now we just have to put it in the right spot. And that's it. Let's go ahead and start our node. And we'll see how well we did. Oh, we did well. No errors. Occasionally I do still run into errors that I have to fix where, oh, I forgot to download Cosmovisor. I forgot to I forgot to change the username in the service file. So, I'm not perfect. I still definitely make mistakes. So we'll just let it run here and see if it'll state sync, which it should. Just have to let it connect to some peers. Oh goodness, it's already 1:45. What time is it there? Let's see. I don't know. We've been on it for a while. I think a few hours. Yep, there we go. Discovered snapshot. Yep, snapshot accepted. Good, looking good. How many chunks? One chunk. That's it. So it'll be synced in no time. There we go. We're already running. We have blocks. So we'll do our Ryzen status. Helps if you give it the... There we go. Now, that's not very readable, so you can pipe that into JQ, and that helps a lot. However, if that does not work, what you need to add is you need to redirect the standard error output to standard, I think is what that does. I forget if that's a poor explanation. More to the point is that in order to get it to do the nice output that's more readable, if just the regular piping into JQ doesn't work like that, then just to put in the 2 greater than ampersand 1, and it will fix it. And it makes it much more readable, and we can see without having to dig through there, catching up true. Just run it. And it's at 601.2560. $601.2632. So it's yeah, it's already synced. So I can go ahead and move my keys over if you want to see that part. It's not super difficult. Nor is it super time consuming. So if you want to see the actual migration, let me know. Otherwise, I'll wait until sometime tomorrow. At the moment, I'm inclined to wait until sometime tomorrow, just so that we can make sure we keep the video not stupid long, and so we hopefully have a good recording. Yeah, no doubt. All right, I'm gonna stop the stream, stop the recording.